Hall effect sensor. First, to explain what is a Hall effect. The Hall effect happens when steady state is flowing through it. There's current flowing through a wire in steady state. So electrons would be leaving the negative terminal, going through this piece of metal and returning to the positive terminal. By battery action, they're transferred over to the negative terminal again, and the process continues. If we put a magnet near this wire, there would be created a magnetic field. Magnetic fields for magnets go towards the South Pole and away from the North Pole, so the magnetic field would be in this upwards direction. The velocity of the electrons is towards the left in this green arrow. Then if we do the right-hand rule, V cross B would yield a line pointing towards the back, but remember that the charge is negative, and so it flips over to the front, and the force from the magnetic field is towards the front. Then proton or positive charges would follow what the force says and come to the front, and the electrons would go the opposite way and go towards the back. This creates a detectable change in voltage that we can measure. So if this is used in circuits, the change in voltage would be really small, so we'd have to amplify it. One way I learned that we could amplify a signal would be through operational amplifier, where the output is proportional to the difference between the non-inverting input and the inverting input, and it's proportional by a really large A value, so any small difference would become a very large output. We'd have to use a non-inverting amplifier where the inverting input is connected to ground and the non-inverting input is connected to this voltage difference between the two sides. This is used in something I'm really passionate about, which is CrossFit, because we use rowing machines and bikes a lot. So we could use this to measure the speed at which we are rowing or biking by using this setup. So there's a permanent magnet and a Hall effect sensor and a gear. So every time a spoke of the gear goes by the Hall effect sensor and we measure the voltage change, we could see some changes in the voltage, and this creates a square signal. Then with this square signal, we could just compute the revolutions per minute by counting pulses per second, and then revolutions per minute can be displayed on our machine. So a lot of the information for this video came from this YouTube video on Hall effect. I also read this blog about Hall effect, and I first realized that Hall effect would be included in some of the machines I use every day by this blog.